If you have a really complicated circuit, one of the first ways to figure out what's going on is to follow the path of power. So we know the power starts at the plug over there, and we can see it comes in and it goes through these red wires which go to the front panel switch. And then to the good chance that that switch right there interrupts the electrical current from flowing. So then it goes back, the power goes back through one of the wires back to this little device down here, which if you notice really closely on the power entry module, there's a voltage selection on there. So we could select whether this runs at 220 volts or 110 volts. So from there, there's some switching going on in there. And if we pull some of the wires out of the way, we could see wires are coming out of the power entry module, which is down there. And they're going into this big thing right up here, which is a transformer. What that does is it changes the 120 or 240 volt AC into lower voltage for use in the circuits. And I could see there's two circuit boards. There's one over here, and there's one over here, which are fairly similar looking. And like there's capacitors and transistors on both of them, and they almost look like they're mirror images of each other. If we look at the front panel, we could see that the two power supplies that are adjustable are really mirror images of each other. So maybe they're using almost the same exact circuit to run both of the power supplies. Our preliminary testing showed that only the right-hand power supply was bad. Therefore, it might make sense to try to remove it. So we can see it has these two knobs right here. We could pull the knobs off, and then we can get down to the controls to unscrew them. And then, lo and behold, we have Phillips screws holding the circuit board into the panel. First, we'll take off the knobs. So if we notice, there are no set screws in these knobs, so they're probably a press fit. So we carefully put a screwdriver in there and try to coax the knob off, which it does. We got one knob off. Second knob comes off. And then if we look at the front, there we could see there is a little nut that's possibly holding on the potentiometer onto the front panel. So we'll need to take that off. So in addition to that, we need to remove the screws from the side panel. These screws right here. Once again, the number 2 screwdriver came in handy. We removed the top piece of metal that held the circuit board in, removed a few screws, and now the circuit board is loose. So we also cut the wire ties that bundle all the wires up neatly. So that, by doing that, we hope we could try to separate the board from the housing a little bit. Maybe there's some connectors that we have to disconnect, like this one right here, and then we can get the board out. So what I did in order to disconnect that was I put my fingernail underneath this little piece of plastic right here, and I pulled it up, and when I did that I could pull this out very easily. So there are a few more in there. This one, pulled that one out. And it's best to leave as many things connected as you can, because you might not know where they go, or you might want to try to turning it on, in a safe way, and diagnosing the problem while it's turned on. We have the circuit board removed now, and it's out on the workbench. And we can see just by looking at the board that it's labeled very nicely. Like there's a lot of silkscreen, we call it, on there, which tells us what all the different connections go. But therefore, if we weren't videoing this or taking pictures of it while we were disassembling it, we wouldn't have to rely solely on those pictures to connect it. We should just be able to find the right connectors and then connect them back together. So continuing with the power flow, so earlier we talked that the power is converted from a high voltage AC to a low voltage by this power transformer. And we could see there's this bundle of wires here that goes down to this point on the board. It enters the circuit board right here. So there's also a bunch of fuses right there. Those are these items right here, these silver cylinders. And then right after that, these little black boxes right here, those are full wave rectifiers. Those convert the AC voltage into DC voltage. Then right after that, there's some filter capacitors. These large cylinders right here are capacitors, and they're what we call electrolytic capacitors, and those smooth out the DC into very smooth DC, which is, has no ripples on it. So that's important because this is a DC power supply. Then there's a ton of other stuff up on here. So there are these little things right here with the legs, which are op amps. So there's a few different op amps on there. And if you look closely at them, you'd notice it says LM741, which is a classic op amp. It's been around for a long time, but it still is in wide use. These blue boxes are relays. Those are electromagnetic switches. So this right here is a larger rectifier. So some larger capacitors. And then moving over to the front, these are heat sinks. There are transistors on there. They get hot. They dissipate heat. Then we have these two knobs right here. These are input controls. This was our current control, and this was our voltage control. So if you recall, we were having trouble controlling the voltage. And what this is a variable resistor inside this thing. As I turn this knob, it changes the value of the resistance. So there's a good chance, being a mechanical part, and being that when I turned that knob it wasn't properly adjusting the voltage, that maybe that part is bad. And we can troubleshoot that part using our voltmeter. So if we want to check the potentiometer function, we can use the probes on the multimeter set to resistance and put them on these lugs right here. So the potentiometer should have a fixed value across the two lugs. It appears that it's 22 kiloohms. Then between one lug and the wiper, it's showing megohms. So right there, that's showing a problem. And here it's not even connected. That's saying that this center terminal right here, where the black probe is plugged in, is not even really electrically connected to the two outer terminals. So that's what we call a smoking gun kind of problem, and we usually like those kind of problems because it's obvious that there's a problem with this particular part in the circuit. And when we have that, then we could just try to change the part, and hopefully that'll solve the problem.